Significant figures are an important topic in chemistry, and they're really important because it has to do with the precision of our measurements, and significant figures reflect how precise our measuring equipment is. We're going to talk about this a lot more throughout this class, and especially in the lab portion of the class. So for now, what I want you to remember is that significant figures are any non-place holding digits in a measurement. So that means just pretty much any digits that signify the precision of the measurement we're trying to make. And so the more significant figures that we have, or the more precise our measurements, the greater certainty we have of that measurement. So how do we determine if a digit in a number is a significant figure? We have a series of rules in order to determine which digits are significant. So the first rule is that all non-zero digits in a number are significant. So that's pretty easy. First rule is nothing really to worry about. We just have to look for all of the numbers that are not a zero, and we know that those ones are significant digits. So in this first number here, we have 1.3820. The 1, the 3, the 8, and the 2 are all significant. We will come back to the 0 in a moment. And in our second number, we have 0.8307. Again, we'll come back to the zeros, but we know based on rule number 1, the 8, the 3, and the 7 are significant digits. Rule number 2 is that interior zeros are significant. What I mean by interior zeros is zeros that come in between two non-zero numbers. So this first number, the 1.3820, doesn't have any interior zeros, so we're going to skip this rule for that number. But our second number does have an interior zero, and that's this zero right here, the one in between the 3 and the 7. So based on rule number 2, that zero will also be a significant digit. Rule number 3 is that zeros to the left of the first non-zero digit are not significant. So this one's a little bit confusing because you have to kind of wrap your mind around, okay, which zero are we looking at here? Again, in this first number, we don't have any zeros that go by rule number 3, but in the second number we do. So we want to look at the first non-zero digit. So the first non-zero digit here is this 8. And then if we look to the left, we have this 0 here to the left. And that means because it's to the left of the first non-zero digit, it is not a significant digit. It is not significant. So far we have all the non-zero numbers, zeros in between non-zero numbers, and zeros to the left of non-zero numbers. So now we have to consider our trailing zeros, so the zeros at the end of a number. And this rule has multiple parts. So we have to look to see where our decimal point is. So trailing zeros that come after a decimal point are significant. Trailing zeros before the decimal point and after a non-zero digit are significant. So basically we have to look at our non-zero numbers. So in this case, in our first number here, we have a trailing zero, so a zero at the end of a number. And that 0 comes after all of the non-zero digits. And it also comes after the decimal point. Because it comes after the decimal point, we know that this 0 is a significant digit. This second number here, we don't have any trailing zeros, so we can skip rule number 4 for our second number. But I really wanted to illustrate what this second part of this rule means, so that's why I included this third number here. So here we have 3 different trailing zeros. We have zeros after the decimal point, so that's these 2. And then we have a trailing 0 before the decimal point that is after a non-zero digit. So let's look at the first one, or let's look at the ones after the decimal point first. So because these 2 zeros here, these ones, come after the decimal point, we know that these are significant. This 0 obeys a different part of the rule. This 0 comes before the decimal point, so the decimal point's here, but after a non-zero digit, which is this 2. because it comes in between, this one is also a significant digit. So if we look at our two numbers that we have been using as examples through this whole time, we know that 1.3820 has 5 significant figures. 4 of them are non-zero digits, and one of them is a trailing 0 after the decimal point. For our second number, 0.8307, we have 4 significant figures. We have the 3 non-zeros, we have an interior 0, but this 0 up at the front is not significant, so only these 4 are significant digits. So what do we do for numbers that don't have a decimal point, but perhaps have some zeros? So this is where it gets a little bit confusing. If we have all non-zero digits, we don't really have to worry because all non-zeros are always going to be significant. So this number, 12,345, has 5 significant figures. All the digits are non-zero. No worries there. But for a number like 165,390, we have a trailing 0 there, but we don't have a decimal point. We know that in order to be significant, it either has to come after the decimal point or before a decimal point and after a non-zero digit. So what do we do here? Well, in this case, we don't consider our 0 to be a significant figure because we don't have the decimal point to tell us that it's significant. But this kind of creates a little bit of a problem if we're trying to create a measurement, and let's say that that 0 is the final number of our measurement. That is our estimated value when we're making a measurement. And again, we're going to talk about exactly how measurements are made more in the lab portion of this class. But let's say that we needed the 0 in our measurement, which means that it is significant. So how do we show that? Because the way that it's shown in this example, it's not written to be a significant figure. If we want to show that a trailing 0 is significant, it's always best to use scientific notation just to avoid any confusion. So the way you would write that number is 1.65390 times 10 to the 5th. So now you can see that that 0 comes after the decimal point, as well as after a non-zero digit. And so that means that it is, in this instance, a significant figure. So we're going to do a little bit of practice. I recommend that you pause the video here to give yourself a couple of minutes to work through this problem, and then unpause it, and we're going to go over all of the answers. This question is asking you to underline the significant digits and write how many significant digits are present in that number. So for our first example, we have 270. The 2 and the 7 are both significant digits because they're both non-zero numbers. And that 0 is not significant because it's a trailing 0 with no decimal point. So we say that this number has 2 significant figures. In our second example, we have 5.0. So the 5 is a non-zero, that one is significant. And the 0 comes after the decimal point, which means that that 0 is also significant. Whenever we see times 10 to an exponent, that part of the number, so this part here, is not counted as a significant digit because these are just place-holding zeros. So we don't count these as significant. So this number also has 2 sig figs. For 0.790, we have 3 significant digits. That's because we have a leading 0. Remember, leading zeros are not significant. We have 2 non-zero numbers, and then a 0 after the decimal point. In our next example, we have 1.47. All of those are non-zeros. Remember, the 10 to the negative 4 is not considered significant, so this number also has 3 significant digits. And then we get to 4,580. Notice again, we have a number that doesn't have a decimal point even though we have a trailing 0. So because there's no decimal point, we can't assume it's significant. We have to assume it's not significant. So only our non-zeros in this example are significant digits. In this next example, we have a lot of zeros going on here. So which of these numbers are significant? We know the 4 is going to be because it's non-zero. And then these two following zeros, these trailing zeros, will also be significant. So what about these ones? Why are these zeros not significant? Well, this one is before the decimal point and before all of the non-zero numbers. It's not significant. Even though these digits are after the decimal point, they come before the first non-zero number. So because they are a leading zero, these ones are also insignificant, which means that this number has 3 significant digits. So for 1,000, again, this is another example where we don't have a decimal point to tell us where our significant digits are. So we have to assume that the 3 zeros are not significant. Only the 1 is going to be significant in this instance, which means that this number has only 1 significant digit. And finally, we have 7.3 times 10 to the negative 9. We have the 7 and the 3 are both significant because they are non-zero numbers. The times 10 to the negative 9 is just telling us where the decimal point is. So we don't include this as significant. So in this case, we have 2 significant digits.